Do your reinforcement learning agents struggle to adapt their behavior to changes in their environment? Are you trying to understand the boundaries of their generalization capabilities? Then context may be for you. We, Theresa and I, Carolin, present you Contextualize Me, the case for context in reinforcement learning, which is our latest research. This is joint work with the Leibniz University Hanover and the University of Freiburg, and it tackles context, what does it mean, and what can we do with it. But first, before we show you what we can do with context and how we build our benchmark, what even is context? How do we define it formally? Normally, in reinforcement learning, we have MDPs, Markov decision processes, which are defined via a state space, an action space, transition dynamics, reward function, and initial state distribution. Often we also define the discount factor within our MDP definition. So now what is different? How can we get context into our definition? For this we have contextual MDPs, which are also defined by the same state and action space per single MDP, but now we have a transition dynamics function and a reward function which are different per context. We have an example for this. You can think of a CMDP as a collection of single MDPs, all with the same state and action space, but with different transition matrices, for example, which you can see here on the slide. Now, starting from the abstract notation, we want to illustrate an example, which is in our case pendulum. You can think of context as parameters of the environment, shaping the environment and influencing the dynamics and the behavior. For example, in pendulum we have the mass m of the pendulum, the length of the pendulum, gravity, and also the maximum velocity. And all those parameters influence the environment behavior, but not the general problem itself. So in our case, this is the context. And now we can extend our normal environment with our contextualization, which you can also see here. Now we have a set of 3 different contexts with different values. For example, for one we have a higher gravity, for one we have a lower gravity. One pendulum is longer than the other. But the important thing is the principle of the environment doesn't change, and the task the agent needs to solve doesn't change.
Examples of context on different environments include acrobat here with a very long length, car racing where a race car now has a trailer, and point mass where we can change the starting and goal locations for the agent. RL agents can't usually generalize well to such different contexts as we see in this example plot. Instead, they need to learn about the variations in the environment in some more explicit way. And this is where Carl comes in. Carl can help understand the generalization capabilities of agents. It's a benchmark that uses existing popular environments and extends them with context features. These can be used in different ways. We can use the almost always interpretable context features to inspect where exactly our agent does well or poorly. And of course, we can also precisely define training and test distributions for comparing different agents. In this example, simply adding the context to the state already improved generalization on the test set.
Theresa told you how context can help us decompose generalization tasks, and that Carl is a great tool for interpreting generalization performance in contextual environments. You can learn more about both in our TMLR paper Contextualize Me. So do your agent a favor and give it a bit of context for its task. It might reward you with better performance.